Hello guys, today we are gonna talk about how to find distance from point to a straight line. We have two methods to solve this problem. The first method, let D be a straight line where V is a directed vector of the line D, and let A be a point does not belong to the line D. Then the distance from A to the line D is the measure of the segment AB, where B is the orthogonal projection from A to D. To find this distance, we need two steps. Step 1, finding the coordinates of B. AB and D are perpendicular. Then AB vector dot V vector equal to 0. Solving this equation gives the coordinates of B. Second step, let's finally calculate AB. Let's go to an application. Let D be a straight line of parametric equation x equal 2t plus 1, y equals 3t minus 5, and z equal minus t. And take a point of coordinates 1, minus 5, 1. The first question is to show that A does not belong to D. Second question is to calculate the distance from A to D. First question, we need to show that A does not belong to D. Substitute the coordinates of A in the line D. Then 1 by x minus 5 by y and 1 by z. We get t equals 0, and t equal minus 1, which is impossible. Then A does not belong to D. The second question is to find the distance from A to D. The distance from A to D is the measure of the segment forming by the point A and the orthogonal projection from A to D. So take M, the orthogonal projection of A on D. Then the distance from A to D is AM. Step 1, finding the coordinates of M. We know that M is a point on the line D. Then the coordinates of M as D. So M is 2t plus 1, 3t minus 5, and minus 2. And we know that AM perpendicular to V, to the line D, then the vector AM dot V vector equal to V. By finding the coordinates of AM, we get AM xm minus xa, ym minus ya, zm minus za. We get AM 2t, 3t minus t minus 1, and take a directed vector of line D from the parametric equation of line D. So V is 2, 3 minus 1. AM vector dot V vector equal to 0. X prime plus y prime plus z prime equals 0. Give the values of t. So we need to find the distance AM. Substitute this values t in the vector AM. We get the vector AM. And by calculation the norm of this vector, we get AM equal radical 182 over 14 units. This is the distance from A to the line D. Second method. Now let D be a straight line having V directed vector and a point does not belong to D. To find the distance from A to the line D, use a second method. We need to take a fixed point on the line D. By example, let B be this point. Then the distance from A to the line D is the norm of the vectorial product of AB by V directed vector of D over norm of V. Let's prove this. As we know that the distance from A to the line D is the measure of the segment forming by the point A and the orthogonal projection from A to D. It's H. So let's prove that this distance equal to AH. We know that the norm of vectorial product AB and V is equal to norm of AB times norm of V times sine the angle between AB and V over the norm of V. By cancel norm of V and norm of V, since it's not equal to 0, and by replace sine ABV by opposite over hypotenuse, it's equal to AH over AB, and by cancel AB and AB we get AH. Then we can use this rule to find directly the distance from a point that does not belong to a line to this line by taking a fixed point on line D and apply this rule. Let's go to an application about this. Let D be a straight line of parametric equation x equal 2t plus 1, y equals 3t minus 5, and z equal minus t, and take A be a point does not belong to D, defined by its coordinates 1, minus 5, 1. The question is to calculate the distance from A to D. We need at first time to take a fixed point on D. Then for t equals 0 we get b1 minus 5, 0, a fixed point on D. The distance from A to D by applying the rule, it's equal to norm of AB times norm times V over norm of V, where V is the direction vector of V. Let's find the coordinates of AB and V. Then AB xb minus xa, yb minus ya, zb minus 1a. We get AB 0, 0, minus 1. And a direction vector of the straight line D from its equation, it's 2, 3, minus 1. By finding the vectorial product of AB and V, AB vector cross V vector, we get 3i minus 2j. Then AB vector cross V vector, it's 3 minus 2, 0. Let's find now the norm of this vector. We get the norm of AB cross V, it's equal to radical 13. And by calculation the norm of V, we get norm of V equal radical 14. Then the distance from the point A to the line D is equal to radical 182 over 14.